Looking at exercise 8 from section 2.2, we want to write the standard form of the equation of a circle with endpoints of a diameter at the points 9, 4 and negative 5, 7. So whenever you're given the endpoints of a diameter for a circle, the midpoint of those 2 points is going to be your center. So your center equals the midpoint of these 2 points, which is 9 minus 5 divided by 2. So I'm adding the x coordinates together and dividing that sum by 2. And that gives me the x coordinate of my center, which is my midpoint. And then I'm adding the y coordinates together and dividing that sum by 2. So I get 4 divided by 2, 11 over 2, which is 2, 11 halves. So that's actually the center of my circle. Another thing that I need to find out is the radius of the circle. So the distance from the center to either one of these endpoints will be the radius. So remember, just think about it. If I have a circle, and let's do a little bit better circle than that. Okay, so here's a better circle. So in other words, if I have the center, and then I have a diameter, so in our particular case, from the center to one of the points, which is on the endpoint, which is an endpoint of our diameter, this will be the radius. So that would mean that I need the distance formula. So I need the distance between this center and either one of these points. So I'm going to use the 9, 4. It doesn't matter which point you use, because this distance is the same. If you're using this point, endpoint, the distance is still the value of the radius. If you use this other endpoint, the distance is still the value of the radius. All right, so we need the distance formula, and I'm going to use the 9, 4 simply because both of its coordinates are positive. And I'm going to look at the difference in the x coordinates and square that difference. So the x coordinate of the endpoint I'm using is 9. The x coordinate of the center is 2. So that's the change in x that gets squared. And then I'm similarly going to look at the change in y and square that. So the y value of my endpoint is 4, and the y value of my center is 11 halves. So I have the square root of 9 minus 2 squared, which is 7 squared, plus 4 minus 11 half squared. So 4 is 8 halves. So this is the square of 8 halves minus 11 halves. So I have 49 plus the square of negative 3 halves. which is 49 plus 9/4. And then I need to, in order to add those, I have to write 49 as a fraction whose denominator is 4. So I multiply 49 over 1 times 4 over 4. And now I'll be able to add because these will have a common denominator. So this is 196 over 4. Oops, 196 plus 9 over 4. Okay, so this is equal to, if we add 9 to 196, we get 205 over 4. The quotient rule of radicals says I can take and apply the radical to the numerator and to the denominator. So I get and really technically I can leave it like this. I'm going to just leave it like this. All right, so we have our, I'm going to leave it, I could keep going and write it as the square root of 205 over 2. That's actually not necessary. I'm going to leave it as this. This is actually my radius. So I'm asked, if I look back at the problem, I'm asked to write the standard form of the equation, which I'm now able to do. I have the center, and I have the radius. So the center is the point 2, comma 11/2. The radius is the square root of 205 divided by 4. So when I go to write the standard form of the equation, I get the square of x minus the x-coordinate of the center plus the square of y minus the y-coordinate of the center equal to the square of the radius. So the only thing I would simplify here is that square of the radius. When I square a square root, I simply get whatever my radicand was. And that's where the 4 comes from in the 205 divided by 4 of the standard form of the equation. So this is the correct answer, and this is how it is obtained.